A 100-watt bulb B1 and two 60-watt bulbs B2 and B3 are connected to a 250-volt source as shown in the figure. B2 and B3. These ones are 60 volts. So this one and this one. Well, the first one is 100 volts. This one is 100 volts. Okay. Now we are asked W1, W2, W3 are the output powers of the bulbs B1, B2, B3 respectively. Okay. Then which one is the greatest? So what we have to do here is the source is similar, 250 volt. The point is bulb P1 is 100 watt, 60 and 60 connected to. We'll have to solve it with different resistances in mind. This is some resistor R1, this is some resistance R2, and this is some resistance R2 again. What we'll have to see is that R1 does not get the full 250 volts that it is rated on. So when we say it is a 100 watt bulb, we believe that it is a 100 watt bulb in 250 volt scenario, but we don't get a whole 250 volt of voltage difference on this resistance. So we'll have to solve it in a slightly different fashion. First of all, we'll have to find the resistance R1. R1 is going to be equal to V square upon P, which is equal to 250 into 250 upon 100. Let's just keep it this way and not solve it further. R2 can be found out in a similar fashion, 250 into 250 upon 60. Alright, we keep it just like this. Now when we solve for the wattage in this one, or the power consumption, W3, let's solve for W3 first. That would be equal to V square upon R, and V square is again 250 into 250, and R is again 250 into 250 divided by 60. So our answer is 60 watts, and this should have been the answer. It's the correct answer because in this scenario we are getting 250 volts of potential difference across R2. Whereas the problem is going to occur in the above picture. So what we can do in the above picture is we can try to find out how the potential difference is going to be distributed in both of these bulbs, or we can simply solve for any one of them. Let's solve for W1, and we obviously know that W2 is going to be smaller than W3. So first of all, you can check for options where W2 is smaller than W3. W2 smaller than W3, greater, equal, and that gives us the only possible answer in this question, which is D only. So if you do want to end this question right here, this is also the right place to stop. Okay, but if you do want to solve for W1, you can solve it for you can solve it in with this equation, with this formula. W1 will be equal to 250 squared divided by 250 squared into 1 by 60 plus 1 by 100. This is a formula for parallel consumption, and the answer comes out to be 600 upon 16, which is 37.5 watts. So in this situation, it uses the minimum least amount of power, which is W1 will be at the smallest location.